Okay, today we're going to talk about adding and subtracting mixed numbers. We'll start off by saying there are different ways to do these problems. I'm going to show you my favorite way because it's always the same set of rules and you don't have to worry about borrowing or regrouping. So if you have a mixed number, step number one should be to change that to an improper fraction. From there, all the steps are the same that we learned last time for adding and subtracting just common fractions that are not mixed numbers. You would find common denominators if you need to. Then you will add or subtract the numerators and keep the denominator the same. And anytime you work with fractions, when you get to your final answer, you want to check it and see if it's simplified. If it's not, you want to simplify it. Answers should always be in the simplest or smallest possible form. So let's jump right in and do an example. So this first problem is 7 4/9 plus 10 2/9. So to change 7 4/9 to an improper fraction, we'll do 7 times 9 is 63, plus 4 is 67. Keep the denominator of 9. And then 10 2/9, we'll do 10 times 9 is 90. And 90 plus 2 is 92, and keep the denominator of 9. So we're happy about this because we already have common denominators. So we're going to add the numerators together. We're going to do 67 plus 92, we get 159, and we keep the denominator the same. So now we want to ask ourselves if this is in simplest form. Is there a number that we can divide into 159 and 2 evenly? And in fact, there is. Let me show you a little shortcut that I love. If you add the digits of a number like 159, if we added 1 plus 5 plus 9, we would get 15. If 15 is divisible by 3, so is the entire number. Do you guys see I made a mistake right there? That should be a 9. All right, moving back to where I was. Okay. We know 9 is also divisible by 3, so 15 divided by 3 is going to be 53, and 9 divided by 3 is 3. I'm totally fine with this as your answer, as an improper fraction in smallest form. If you'd like to write it as a mixed number, you could instead change that to 17 2/3. I will also accept that as a right answer. I prefer the improper fraction on the left, actually, but I would accept either. All right, moving right along. For this first problem here, 8 times 6 is 48, plus 5 is 53. Keep the denominator the same. 2 times 3 is 6, plus 1 is 7. Keep the denominator the same. It's a subtraction problem. We want to have common denominators, so I think a good one would be 6. This one already is 6. For this one, if I'm going to multiply 3 times 2 to get 6, then I want to multiply 7 times 2 to get 14. So I'm going to subtract the numerators, and 53 minus 14 is 39. I'm going to keep the denominator of 6. This is not in simplest form because I can divide 39 and 6 both by 3 to get 13 halves, or if you want, you can make that 6 1/2. I would accept either one as a right answer, but I actually prefer the improper fraction on the left. For this next example, this is not 3.7, this is actually number 3. So if we have a whole number like 7, I'm going to make that 7/1. 1 1/2 is 3 halves, so I need a common denominator. A good common denominator for these two would be 2. So 7/1 becomes 14/2. Because if I have to multiply 1 times 2 to get the 2, then I have to multiply 7 by 2 to get the 14. And then minus 3 halves is going to give me 11/2, or 5 1/2. Again, either one of those answers would be correct. I prefer the one on the left. And the last example on this side, I'm going to change these to improper fractions, so let's do that. 11 times 3 is 33, plus 2 is 35. 5 times 2 is 10, plus 3 is 13. A good common denominator would be 15. So I need to multiply 35 times 5. I get 175. And then I need to multiply 13 by 3, and I get 39. When I subtract 175 and 39, I get 136 over 15. I don't think I can simplify that anymore, so that's a good answer, or I could change that to 9 and 1/15. Either one of those answers would be counted as correct, either the improper fraction or the mixed number. So that is the front of these notes. Thanks for watching.